Welcome to substitution and inverse trig functions. So just a quick reminder of some of our integrals which resulted in inverse trig functions or which came directly from inverse trig derivatives. The integral of 1 over 1 plus x squared dx was just tan inverse of x plus c. The integral of 1 over the square root of 1 minus x squared dx is sine inverse of x plus c. And the integral of 1 over x times the square root of x squared minus 1 dx is secant inverse of the absolute value of x plus c. So these are three key inverse trig related integrals to keep in mind to watch out for when we are doing integration. So for an example, let's consider the integral of 1 over 1 plus 9x squared dx. So this here looks similar to 1 over 1 plus x squared, which we knew what to do with. So what we're going to do is we're just going to force this into that format of something squared. So this integral becomes the integral of 1 over, actually, let me switch colors. So this is the integral of 1 over 1 plus 9x squared is 3x in parentheses squared dx. So if we set u equal to 3x, we have du equals 3dx, or dx is equal to 1/3 du. And what we wind up getting is that this is equal to the integral of 1 over 1 plus u squared times 1/3 du. We could pull that 1/3 out front. Either way, this is just 1/3 times tan inverse of u plus c. And plugging back in our u, we wind up getting 1/3 times tan inverse of 3x plus c. Now let's take a look at another one. This looks again similar to 1 plus x squared in the denominator, but it's not exactly the same. So this is a closest match to 1 over 1 plus x squared. So we're going to force that format. So if we factor out a 16 from the denominator, we could rewrite this as 1 over 16 times 1 plus 1/16 x squared dx. I'm going to just take that 1/16 all the way out front. Then we have the integral of 1 over 1 plus 1/16 is just 1/4 squared. So this is just x over 4 squared, and then dx. If we set u equal to x over 4, then we have du is equal to 1/4 dx, or dx is equal to 4 du. So we are now looking at 1/16 times 1 over 1 plus u squared. Sorry, this is integral of 1 over 1 plus u squared times 4 du. Which gives us a little more space. This is the same as 1/4 times the integral of 1 over 1 plus u squared du, otherwise known as 1/4 times tan inverse of u plus c. And plugging back in our u, we have 1/4 times tan inverse of x over 4 plus c. So this started off sort of in the format 1 over something squared plus x squared dx. So it turns out we kind of get a general rule for things of that format. So if we want to take the integral of 1 over a squared plus x squared dx, this winds up simply being 1 over a times tan inverse of x over a plus c. Similarly, if we want to take the integral of 1 over the square root of a squared minus x squared dx, and this winds up being sine inverse of x over a plus c. And our last integral, 1 over x times the square root of x squared minus a squared dx. This looks like similar to our inverse secant. So this winds up being 1 over a times secant inverse of the absolute value of x over a plus c. So for all of these, if you get something in this form, you're welcome to jump straight to here, or we can do our sort of factoring out and u-substitution that you saw previously. Also, if you have something in this format or like one of our original integrals, if we have instead of x squared, x to the 4th, you could do a u-substitution setting u equal to x squared and kind of force our one of our inverse trig derivatives to pop up as well. So just note, if we have something like the integral of x over 1 plus, actually not x, let's do integral of x cubed over 1 plus x to the 8th dx. We could rewrite this as the integral of x cubed over 1 plus x to the 4th squared dx. And then this will also be u-substitution. We could set u equal to x to the 4th. Then we have du to be 4x cubed, hence why I needed that times dx. Hence why I needed that x cubed up top and couldn't just use x. Or x cubed dx is equal to 1/4 du. And we wind up getting then the integral of, we would have the x cubed dx becomes 1/4. So we essentially have 1/4 over 1 plus u squared du, or 1/4 times tan inverse of u plus c. And then plugging back in, this becomes 1/4 times tan inverse of x to the 4th plus c. So this is an alternative format of how we might have some sort of u-substitution pop up, other than just the constants differing. So that's u-substitution and inverse trig functions.